Okay, this is part 2 of how do atoms form molecules. So just continue on your notes from the previous video on the same page. So now that we learned how molecules are formed through chemical reactions, now how do we share what molecule we're talking about with other people? The way scientists do this is with the use of what we call chemical formulas. I like the definition a student came up this year with what a chemical formula is. They said it is the ingredients that make up a molecule. And I thought that was a really good definition because it tells us the idea with ingredients. It's not just what do you put in it, but also how many of each one. So the definition I usually write down is more of a book definition. It says this: letters and numbers that show how many and what type of atoms are in a molecule. So you can see the example there is 4H2O. That's the water molecule from above, and I drew a little picture of it down there below my definition. So let's take a look at what do the different numbers mean. So let's start with this little 2 here first, and that's what we call the subscript. We call it the subscript because it's sub as in written smaller down below. Now what does the subscript tell us? The subscript is written to the right of an element, and it tells us how many of that element there are per molecule. So in our case, since the 2 is to the right of the H, that means in each molecule of water there are 2 hydrogen atoms. Okay. So how many of that element there are per molecule? An important thing to note, and this comes up later when we get to balancing equations, is you never want to change the subscript. If you change the subscript, you've changed the chemical compound altogether. So just, you can't change it. All right. What does that number 4 out in front mean? Oop, got ahead of myself. You'll notice that there is no subscript behind the oxygen, and that's because whenever there isn't one listed, we just assume that it is 1, which makes sense because if the element wasn't in there at all, we wouldn't have written it down in the chemical formula in the first place. All right, now let's get to the number 4. The number 4, what is this represented? This is called the coefficient. It's written out in front. And what it does is it tells us how many total molecules there are. So for our example, I think I got some highlighting here. Yep. For our example, since it says 4H2O, what that's going to mean is that there needs to be 4 water molecules altogether. So there's 2, 3, and 4. The coefficient is written out in front, and it tells us how many total molecules there are. So 4H2O would look something like this. 2 hydrogens per oxygen, and then you have to have 4 of those groupings all together. Let's take a look at an advanced chemical formula. It's about as complicated as they'll get for our class. It's right here, Fe3NO3 2. Now you'll notice that we put parentheses on there. Oh, I forgot the little 2. There we go. Now, why do we put the parentheses on there? And it's just a handy way of shortening up the formula to let us know that there's more of whatever's inside the parentheses. So the 2 then tells us that there's that many of whatever's inside the parentheses. So in our case, Fe3NO32 would mean that inside the parentheses you have your NO3. That 2 tells us you got the Fe3, and then you have one NO3 followed by a second NO3. So the real molecule is actually made up of 2 groups of NO3 with one Fe3 out in front. Sometimes students will ask me, Mr. Clausen, why don't we just write it like this? Why not just combine that down to make it simpler? And because in nature, it turns out that NO3 is what we call a polyatomic ion, and it just attaches to the iron in such a way that it's important to have it pulled out like this. So let's do another example where I would have you count how many there are. So here's a complicated molecule, NH42. CrO4. Now let's break that down, what that actually means. Remember that 2 tells us that whatever's inside the parentheses, we're going to have, in this case, 2 of them. It could be 3, it could be 4, but in this case, the subscript outside the parentheses is 2. So to write that, you'd have one NH4, because that's what's inside the parentheses, and then you would have a second NH4, followed by the CrO4 afterwards. So that's what one molecule would look like. But then there's that coefficient in front, so it says you're going to have that. That's what the molecules look like, but you're going to have 3 total molecules. So you have to write everything again, NH4, NH4, CrO4, and then one more time as well. And at this point, then what we want to do is we would start to ask you how many of each atom are there in that molecule. So I'll say, okay, how many nitrogens, how many chromiums, how many oxygens, and how many hydrogens. If we go through this, you can count up the nitrogens. You can see that in this case there would be 6, so you just count them up. There you go. The chromium is kind of nice. There's no subscript underneath it, which means there's just 1 per molecule. And since there's 3 molecules, 1 times 3 is 3. To get the oxygen, in the oxygens, there are 3 sets of 4. So the subscript on the oxygen was 4. So 3 sets of 4 would be 4 plus 4 plus 4, otherwise known as 12. And then the hydrogen is a little bit more in depth to figure out, but we have that 4 as a coefficient twice per molecule, but then also 3 molecules altogether. So what you end up getting is 6 pairs of 4, which is 24. And like I said, this is a more complicated example, but we do use that from time to time. So how do you read a chemical formula? We'll start up here at the top. There's the chemical formula is the ingredients that make up the molecule. It's a mixture of letters and numbers that tell us how many and what type of atoms are in a molecule. The little numbers underneath are called the subscript. They tell you how many of the element you have to the right per molecule, and the big number out in front is called the coefficient. It tells you how many molecules there are. If you end up seeing something with parentheses, the subscript behind the parentheses just tells you how many of that things there are that are inside the parentheses. So for in our example here, there's a little 2, so that means there's 2 of whatever's inside the parentheses of the NO3s. That's it. If you have any questions, come see me in class.